forget to like and subscribe this channel.
Now we will continue with the second part of lecture 1. So for the learning outcome in this video, you should be able to define gas law, which is Boyle's law and Charles' law. Then you should be able to sketch and interpret the graph of Boyle's and Charles' law. So Boyle's law states that at constant temperature, the volume of a fixed amount of gas is inversely proportional to the gas pressure, meaning that when the volume of container decreases, therefore the pressure will increase. So the same goes to the other way around.
When the volume of the container decreases, the pressure of the gas inside the container will increase.
So now let's look at this diagram here. When we pull up the piston here, the volume of container will increase. Therefore, the pressure will decrease. And the second diagram shows that the piston is pushed downward. Therefore, the volume of container decrease. Therefore, the pressure of gas in this container will increase. So mathematically, volume is inversely proportional to pressure. Therefore, it is directly proportional to 1 over P at constant temperature and number of moles. So P times V equals to K, which is constant. And for a system that changes pressure and volume, the equation is given as below. P1 times V1 equals to P2 times V2, where P1 and V1 is the initial pressure and volume, while P2 and V2 is the final pressure and volume. This is the graph to show the relationship between pressure and volume. So P is the y-axis and volume is the x-axis. So we can see in this graph that pressure and volume is inversely proportional. If we plot P against 1 over V, it will obtain a positive gradient. It means that pressure is directly proportional to 1 over V. If we plot volume against 1 over P, we will also obtain a positive gradient. So it means that volume is directly proportional to 1 over P. But if we plot P times V against P, we will get a horizontal line, meaning that P times V is constant. Now let's look at example 1. This is actually simple calculation for Boyle's law. A sample of oxygen gas occupies a volume of 2.0 liter at a pressure of 180 m. Calculate the pressure of the gas if the volume is then increased to 5 liter at a constant temperature. So the information given in this question is P1, where the value is 180 m. V1 is 2 liter. P2 is unknown. And V2 given is 5 liter. So we just have to use the relationship P1 times V1 equals to P2 times V2. Then just substitute all the values given into the formula. So we will get P2 equals 2.5 atm. So in this example, the initial volume is 2 liter and the pressure is 180 m. But if we increase the volume to 5 liter, the pressure will increase to 2.5 atm. Now we'll continue with Charles' law. So Jacques Charles observed that, that at constant pressure, the volume of a gas expands when heated and contracts when cooled. When the hot air balloon is flying high up in the sky, the gas inside the balloon is actually heated using the flame. But if the balloon is going to land down, the air inside the balloon is cooled down so that the volume of the gas inside the balloon will decrease. So at constant pressure, the volume of a fixed amount of gas is directly proportional to the absolute temperature of the gas. So V is directly proportional to temperature at constant pressure and number of mole. Therefore, volume is equal to K, which is constant, times temperature. Or we can rearrange this relationship V over T equals to K, where K is the constant. For a system that change temperature and volume, the relationship is given as below. V1 over T1 equals to V2 over T2. V1 and T1 is the initial volume and temperature, while V2 and T2 is the final volume and temperature. So keep in mind, to use this formula, you have to ensure that temperature is in unit Kelvin. So to convert temperature from degrees Celsius into Kelvin, you just have to add the temperature given in degrees Celsius by adding 273.15. So if we plot volume against temperature, we will obtain a straight line graph with positive gradient, but the x-intercept will be slightly on the left, which is on negative 273.15. But if we plot volume against temperature in Kelvin, we will have intercept at 0. Now let's look at example 2. A sample of carbon monoxide gas occupies a volume of 3.2 liter at 125 degrees Celsius. The sample is then cooled at constant pressure until it contracts to 1.45 liter. We have to calculate the final temperature in degrees Celsius. So V1 in this question is 3.2 liter. T1 is 1 to 5 degrees Celsius. So we have to convert into Kelvin before we insert into the formula. So you will get so V2 given is 1.54 liter, and we have to calculate the final temperature in unit degrees Celsius. So just insert into the formula V1 over T1 equals to V2 over T2. So 3.20 over 398.15 equals to 1.54 over T2. So we will get 191.61 Kelvin. So to convert into degrees Celsius, just subtract with 273.15. So you will get negative 81.54 degrees Celsius. The combination of Boyle's law and Shell's law is given as below. We know that volume is directly proportional to 1 over P, and volume is directly proportional to temperature. So if we combine both of these relationship and volume is the subject, so we will get volume is directly proportional to T over P. Now rearrange this formula. So we replace this sign with equals to and put a constant. So you will get V equals to K T over P. Now rearrange this formula. So we will get PV over T equals to K. So for a system that changes in pressure, volume and temperature, the relationship is given as below. P1 times V1 over T1 equals to P2 times V2 over T2. Now let's look at this example. So a sample of methane gas occupies 25.5 liter at 298.15 Kelvin and the pressure given is 153.3 kilopascal. Then we have to find the volume at STP. Now let's list down all the information given. So V1 given in the question is 25.5 liter. The initial temperature is 298.15 Kelvin and the initial pressure is 153.3 kilopascal. So at STP, it means that standard temperature and pressure, the temperature is 0 degrees Celsius and the pressure is 1 atm. So you have to convert the temperature into Kelvin. And since we have pressure in different units, P1 is given in kilopascal and P2 is in atm, so you have to convert one of them into the same unit. So let's convert the initial pressure into atm. To convert into atm, just divide the pressure given in kilopascal by 101.325. Then you will get the answer in atm. So you will get 1.513 atm. So 0 degrees Celsius is equal to 273.15 Kelvin. So after all the conversion unit, we can insert the values into the formula. P1 times V1 over T1 equals to P2 times V2 over T2. Just substitute all the values given into the formula. P1 is 1.513. V1 is 25.5. T1 is 298.15. P2 is 1 atm. V2 is unknown. And T2 is 273.15. So finally, you will get the answer for V2. So you will get the answer 35.35 liter.